Students, welcome to class 11 physics class. Today we discuss the last topic of this chapter, that is free oscillation, forced oscillation, damped oscillation and resonance. So first of all we discuss about the free oscillation or undamped oscillation and forced oscillation and the resonance. So free oscillations means we can say that if a body is capable of oscillation is slightly displaced from its position of equilibrium and left to itself, it starts oscillating with a frequency of its own. That means it is undamped. Another way we can say that this free oscillation, it is called undamped oscillation. In the absence of dissipative force, and the body vibrates with a constant amplitude that a we know that what is the amplitude. The body or the object will vibrate with that constant amplitude. The amplitude can neither be increase or not be decrease, and fixed frequency is fixed. Later I will show you the diagram. That such type of oscillations are called undamped oscillation. This is one features of free oscillation. So we can say that the free oscillation is also called undamped oscillation under the condition in the absence of dissipative force, and if the body vibrates with a constant amplitude and a fixed frequency. So this is if no more external forces are applied to the system, the object will displace from its own position and it will oscillate about its own frequency. That is called free oscillator. That object is called free oscillator, and that oscillation is called free oscillation. Now if a force is continuously or the repeatedly applied to keep the oscillating going, that is called force oscillation. If we can apply the force continuously or repeatedly, after some interval of time it will be happen. After irregularly or irregularly, if we apply a force on it for the oscillating, that type of oscillation is called force oscillation. So we can say that when a body oscillates under the influence of an external periodic force, not with its own natural frequency, okay, it will not oscillate with its own natural frequency, but with the frequency of the external periodic force, its oscillation are said, that type of oscillation are said to be forced oscillation. So I think it is clear that the difference between the free oscillation and the forced oscillation. In a free oscillation, the object will vibrate with its own frequency. Once if you apply the force, after that nothing, it will displace and then it will continuously oscillate with its own frequency, own natural frequency. But in a forced oscillation, the body will oscillate under the influence of external force, not with its own natural frequency but the frequency of that external force, and with the but with the frequency of external periodic force. That type of oscillation is said to be forced oscillation. Okay, if you want to example, when the free end of the string of a simple pendulum is held in hand and the pendulum is made to oscillate by giving jerks by the hand, the pendulum execute forced oscillation. Its frequency is same as that of the periodic force exerted by the hand. Many examples are there. I will just give you one example. This is one example of the free oscillator and the force oscillator. Oscillator means that object or that system is called oscillator, and the phenomena that is called oscillation. So here two mains are there. One is, if the swing is pushed just once, it acts as a free oscillator. Just once he pushed once, and after that he will not apply the force. So the who is seated over there, it acts as a free oscillator, and because of the damping effect, that because and the rear air resistance also be there, it will come to rest. Okay. If the swing is pushed, each time it reaches a certain point, it behaves as a force oscillator. That means free oscillator, when once time he will pushed, and it is act as a free oscillator. But if repeatedly if he pushes, okay, then that is called, to reach a certain point, that it behaves like a force oscillator and will continue to swing as long as the energy is supplied. Now the question is, if the pusher normally pushes the swing every time it reaches its maximum negative displacement, what would happen if he pushed the swing more often or less often, not after a same interval of time? Okay, if it will swing more often or the less often, he pushed the swing more often or the less often, then what would happen? Let's see. So, if the swing is simply lifted and let it go, will swing with a natural frequency. Just once he pushed, and then it will be free. It will oscillate about its own frequency, or the natural frequency. Natural frequency means own frequency. And this frequency is determined by the many factors are there. And most important, that is the length of the swing from the pivot to seat. Now, how does this, now another one question, how does this natural frequency affect when pusher should push? If the swing is pushed with a long interval between the pushes, the swing will not receive enough energy to replace it. If it pushes a long interval, after such a long time interval, if he push once, then after a 1 hour, then again if he push once, but then the another second person, he will not receive the enough energy to reach its certain point. It will not receive enough energy to replace that lost by the damping, because if 1 hour or if 30 minutes, after 30 minutes if he pushes, then during that 30 minutes, he will, due to the air resistance, it will damp and it will come to rest, then again he pushes. So it is not a continuous oscillation. So they will not, that the second person will not get the enough energy to replace that damping. Damping means due to the air resistance, the speed will be decreases. And if the pushes may be out of synchronized with the swing's natural period of oscillation, this might means that sometimes the pusher would be pushing when his swing is in the wrong location. Now, if the person pushes with a very shorter interval of between the pushes, then what happen? Then again what happen, if the time gap is very short, then once he pushes, the second person will oscillate to and reach its certain point, and before returning back to its initial position, again if the pusher give the force, then it will not apply to the second person. So in this case also, he will not get the enough energy, and he may be again it will be out of synchronized with the natural frequency of swing. So the natural frequency that swing wants to oscillate, that is called resonant frequency. The natural frequency that swings wants to oscillate, it is called resonant frequency. So that resonant oscillation or resonance, it is a particular case of a forced oscillation, because the pusher will pushes, and whenever it will force, it will apply external force. That is a one case of a, this is a two types of case. If the very short interval of time, long interval time, these two types are included in a forced oscillation. So we can say that this resonant frequency or the resonant oscillation, this is also be a one type of forced oscillation. So we can say that it is a particular case of force oscillation in which the frequency of driving force is equal to the natural frequency of the oscillator. Driving force means the external force which is applied by the pusher. Okay. it is equal to the natural frequency of the oscillator itself, and the amplitude of the oscillation is very large. Such oscillation is called resonant oscillation, and the phenomena is called resonance, and the frequency, that frequency is called resonant frequency. That the frequency is called resonant frequency. Clear? Here the definitions are written. So if it will come defined for free oscillation, then you write this definition. And these are the important features already we discussed. And this is a mathematical expression of the frequency of free oscillation. Body with oscillate freely with a natural frequency. That's why it is denoted by nu 0, 1 by 2 pi root under k by m. And these are the some important features of, and this diagram shows that this is a constant amplitude. This is a diagram for free or undamped oscillation. Here you see that the amplitude of this wave, it will be constant. Amplitude is constant, and so the frequency also be constant. This is the definition of the resonant oscillation or the resonance. At the resonant frequency, the if we plot the graph, it will at the top, then it will start decreasing. So at the resonant frequency, it will be the maximum. Oscillation will be the maximum. And these are the examples. An aircraft passing near the building shatters its window panes. If the natural frequency of the window matches with the frequency of sound waves sent by the aircraft engine. Next, the air column in a resonance tube produces a loud sound when the frequency matches with the frequency of the tuning fork. Then what happens if the two frequencies are matches? Then its amplitude will be increases. If the two frequency of two waves are matches together, then its amplitude will be increases. So the sound also be very loud. So this is the resonant frequency. Next is a damped oscillation. Already we discussed damped oscillation. Due to the air resistance, amplitude decreases. Gradually it will decreases, where it is not constant with a passage of time. That is called damped oscillation. The oscillation in which amplitude decreases gradually, that is called with a time passage of time, that is called damped oscillation. And if we see the figure, it is like this way. First it is in decrease, then it will be at rest, like a swing. So whenever the pusher is pushes, it will oscillate with its natural frequency. Due to the air resistance, it is not constant. Okay, that oscillation is not constant. After some time, this oscillation decreases. That means its amplitude decreases with the time, and once it will be stopped, it is at rest. So that is called damped oscillation. And in an oscillatory motion, the friction produces three effects. The friction also be there. Okay, the friction produces three effects. Actually, in practice, most of the oscillation occurred in viscous media such as the air, water, etc. A part of the energy of the oscillating system is lost in the form of heat in overcoming this resistive force. As a result, the amplitude of such oscillation decreases exponentially with the time. This graph shows that one. The amplitude of such oscillator or the oscillation, it will decreases exponentially with the passage of time. And after that, it will after a long time, it will be stopped, or we can say that this oscillation die out. So in an oscillatory motion, the friction, because the air is there, so friction produces three effects. The change in it changes a simple harmonic motion into the periodic motion. It decreases the amplitude of the oscillation. It slightly reduces the frequency of the oscillation. Clear? This is all about the free oscillation, forced oscillation, and under the forced oscillation, that resonant frequency, resonant oscillation, and another one is a damped oscillation. this chapter is completed. Over few numericals are left related, so I will send it later. That PDF I will send in the group. So if you have any problem about this topic, from this chapter oscillation, if you have any kind of problem, please write in a comment box. Thank you very much. Have a nice day. Tata, bye bye.